Hey, Blender Bob here. Let's try something different. A new segment called Ask Blender Bob. The concept is that you find a shot that you really wonder how it's been done. You send it to me and I will try to do a breakdown for you and try to redo it in Blender. So, of course, to a certain level, right? Don't ask me how to do this shot in Blender. Actually, you could, except for the compositing. So there are a few sources you could get this footage. YouTube is the easiest one. You can actually go on a clip, and if you right click on the image itself, you will have copy with the time. So you want to copy the link right there and you paste this in the comment, and you can tell me why you would like to learn about this shot. The other thing you could do is never use a link in the comments that is outside YouTube because it's going to be deleted automatically. I'm not the one who deletes them. YouTube will delete every link that is not from YouTube. All right. Now, another thing you could do is Netflix. So this movie at 25 minutes, 50 seconds, this is the shot. Now you have to understand that I'm in Canada and the choice we have for movies in Netflix in Canada is like a third of what they have in the US. So if I have it, yeah, cool, let's go for it. Disney Plus is another source, so same thing, tell me the film, tell me when it happens. I'm not registered to Amazon, so let's forget about Amazon. Another thing you could do is to send me a clip on my Discord server. The link is in the description. So let's try with the first one. It comes from a certain Robert Riox. What kind of weird last name is that? I cannot even pronounce it. Anyways, he wants to know how you could make this like creature in Matrix 4 that's made by little like bearings and little balls and stuff. How is it done? Could we do this in Blender? Well, we can try. So we need to start with an object, any object. So let's take just a simple plane that will do the job. Okay, that's going to be our master. So I will rename it master. And now in Geometry Node, I'm just going to create a new script. Now we need our main model. So we're going to bring a monkey. Now what you can do is just take the monkey here and drag it into the script right there. And you want to connect this here, Suzanne, into the empty node here. So that this way we can easily swap Suzanne for any other models. We just need to go in the pop-up here and choose whatever object that we want. The next step is to distribute points on the faces. So distribute point on faces, just drag it there. All right, now we got some points on the monkey. Okay, but we don't want these dots. We want to instance a geometry. So what we're going to do is to create an instance on point. So let's go with a sphere. Sphere here. Now I will go back to the master and I will drag the sphere into the script here. And I just need to connect the geometry into the instance. And here we go. Every point has been instanced by a sphere. Okay, they're obviously too big. So I'm going to go back to the original one. And in edit mode, I'm going to scale it down to the size that I want. And okay, let's say that's good. Okay, sorry Susan, you're very nice, but I'm going to turn you off because I don't need you in the scene. All right, I got my points here. If I play with the density, I get more and more dots. We run into this issue here where if the density is too high, the spheres interpenetrate with one another. So there's a solution for this. You go into Poisson Disk. With this, you can set a minimum distance between the points, so this way you can make sure that they will not overlap. I can crank up the density as much as I want. It won't matter too much once I adjust the minimal distance. Once I figure out the right minimum distance, then it will generate only the points that are necessary. Okay, but it looks a little bit boxy. That's because Suzanne is not very high res, so I'm going to add a subdivision node. I would like the points to be generated only from the front of the object, from the y-axis in this direction. So I want to do this according to the normals of the object. We want to use the normal in the y direction. So I got my normal node here. The next step is to separate the normals. We only want the ones in the y-axis. So we're going to do a separate x, y, z, connect the normal there. Then I will connect the output of the y into the selection. It works, but it's in the wrong direction. So we're going to create a math node to invert it. And we're going to set the math node to multiply and the value will be -1. So this way we get the opposite. Now the issue is that it's too sharp. So we're going to create another math node and this one we're going to keep it in add and we're going to play with the value and you will see what it does here. I can tweak it, I can adjust it to cut exactly where I want it. Now we need to diffuse the points that are located at the back of the monkey. So for that we're going to create a set position. This node allows me to move points in the X, Y, and Z axis. We need to get the points that are at the back of the head. So for that, we need to find the position of these points. So I will create a position node. Just like we did before with the normals, I will need a separate X, Y, Z node. I already have one in my scene, so I will just take this one and duplicate it. I have connected the position into the vector and I will take the Y and connect it into the offset. Now you see everything is offsetted in the y-axis. This is obviously too much and it affects the entire geometry, so we need to reduce the range, and we're going to do this using a map range node. What I want to play with here is the from min and from max. Okay, but now they only move in one direction, which is the y-axis. So we're going to change that by adding a vector math node. But this one we're going to set it to scale. Be careful here, you want to be connected to the scale and not the vector. So now I can mess around in every axis, the x, y, and z. Okay, now we need to add some randomness into it. So we're going to create a random value node. And we will connect the value into the vector of the scale node. Okay, so the effect is not that strong, so I'm going to create a vector math node that I'm going to put there, and I'm going to multiply it. Well, I could have used a scale also, it would have done the same thing. Instead of having 3 vectors to choose, I could have used just the scale, but I will try with this. And I use a value because I want to change all 3 of them at the same time. It's easier this way. You may think, why you didn't just use the max instead? Well, you're going to see later. I will create a Musgrave texture to drive the position of the point in space. I just need to connect it in the min. I'm going to change the 3D to 4D because I want it to be animated, so it's going to change over time. Similar to what I explained in my shockwave tutorial that I did before, we want to be able to pull and push the points, not just go in one direction from the texture. So to do this, I create a vector math node in multiply, now -1, -1, -1, and I'm going to put this into the max. So I will get the same values for the Musgrave to pull and push at the same time. So even if I mess with the setting for the texture, it's still pull and push into one direction. There's something wrong going on here. And that's because my random value here was a float, and float is only in one direction. Vector is in x, y, and z. So now I need to reconnect everything this way and this way. And now if I reconnect the value into the multiply here, we get what we want. Okay, some adjustments here and there. Great, now we want it to move over time, so we're going to add a keyframe in the W field here. So frame 0, I put 0, and frame 100, let's try something, I don't know, like 0.1. Add another keyframe here. I want to make sure here that the keyframes are in linear. And now if I move the time slider, you can see all the points moving in the back. If you want this animation to continue forever, select your master node here, and you can see the curve here. At the end, it's flat, so you want to select the curve and go extrapolation to linear. So this way, when we move around the timeline, even if you pass frame 100, it's still going to continue to move. If you look at the face on the model, you can see the points are not randomly applied, but it looks like they follow a particular pattern. The way we could do this is to bypass the distribute points on face. So I just mute it, pressing M, and now you see all the points are distributed according to the vertices of the model. Now, because the model is not uniform, we get this bad pattern. But if we had a very clean geometry with all the polygons exactly where we need them, we would get the similar result as in Matrix. You can also see that on some parts, it's not perfectly uniform. There's some randomness in it. Since we need to move some points around, we will need a set position node. I already have a setup that creates noise in the back of the head, so I'm going to reuse this setup. I will just copy it, duplicate it, Ctrl D, move it around, and connect the output into the offset. But this time, I don't want to do it only in the back of the head, so I'm going to delete these nodes here. So map range, I don't need it. Let's separate XYZ and the position. This time, just to get a different pattern, I'm going to use a Voronoi texture. So I'll just create it here, and I'm going to make it 40 because it's going to be animated with time. And now I can connect the position to the scale. So position to scale. It's obviously too strong, so we're going to create a vector math, and we're going to do a multiply like we do, you know, the usual stuff. So vector math, connect it there, make it into multiply. And now I'm creating a value node to change all 3 of them at the same time. But you know what? Instead of multiply, I could have used another scale. It would have done the same thing because instead of vector for the scale, it's just one parameter that will change all 3 at the same time. It's kind of too late now because it's already recorded. Okay, I need to animate this. You know what? I already had an animation here. So what I'm going to do here is just to copy this as a new driver. And I will animate my second Musgrave texture here. So you just paste a driver. Same thing with the Voronoi. So in the W here, paste a driver. If I play back the sequence, you can see that everything moves a little bit, so it creates a more organic look. We could also randomize the size of the spheres by using a random value node, and we just need to connect it into the scale. So now they will have a scale from 0 to 1. Obviously we don't want 0, so you may want to try something. Let's try 0.75. Well, we can barely tell. 0.5 maybe. Yeah, that's good. Now we can see that the points don't have all the exact same size. I created two shaders on the icosphere at the beginning. The one is the principal BSDF, a little bit of metallic, a little bit of specular, that's it. The other one is simply an ambient occlusion node connected to a RAM so I can adjust it, and then connected straight into the material output. For the render layers, in the beauty layer here, I added two light sources. They are sunlights. So one is a little bit amber and the other one is blue. I also use an HDRI just as a fill light. It's very, very weak. My second render layer is for the occlusion, and all I did was to go into material override here and put my AOC shader. So this way it overrides everything in there, and I can play with the color ramp here to adjust the amount of occlusion that I want. Yes, I did the compositing in Blender. I got my beauty scene, my occlusion, I just multiplied them together. Then I got my background and I just placed it under using an alpha over. That's it. Now, obviously, this is just a demo. The real thing is much more complicated. It was probably done in Houdini. I would assume that they were particles that would stick to the surface. So when the surface moves, the particles would move with them. And there would be like a turbulence field in the back that would just move them around. And if the creature is being created or whooshes away, you probably use a goal system where you have a geometry and you can tell all the particles, well, now you go stick to this geometry here. And sometimes it's easier to do it backwards, actually. Anyways. Is it possible to do this in Blender? At this point, I'm not sure. Eventually, they will take all the particle system and physics stuff and they will bring it into the GeoNode ecosystem. So then, when everything is together, it should be possible. Right now, I don't know. You tell me. Maybe it is. I'm not a particle expert in Blender, so you tell me if it's possible. I'm sure in the comments I will get tons of people replying about this. All right, so now I'm looking for your suggestions and I will be very happy to do the breakdown and try to figure out how it was. Now, speaking of breakdown, it took me, a few hours to develop. It wasn't that long to do, but it's not that complex either. The real thing, I would say, probably took maybe 2 weeks, 3 weeks to develop to get the exact look that he wanted with all the little subtleties and details and everything. And the problem is that this thing is always different from one shot to another. Sometimes they appear in one way, sometimes they go stuck into a little tube, and sometimes they drop from the ceiling. So it's always a different setup. So you can get a setup for the base of the character, but when it's time to do the transitions, it becomes more complicated. So I would say these shots, well, they took a long time to do. All right, so I'm waiting for your suggestions. Bye.